Nato, and in today's video we'll be talking about the secret of scratch tree, X and Y. Remember in our last lesson we talked about the X and Y axis, but remember, for it to move left we need to add the negative side, which is minus. For example, right now, change X by minus 10. This one is change X by 10, so it moves forward, but if we want to make it go backward, we do change X by minus 10 like I did, and now it moves the opposite direction. So now that we have made it to move left, if you now want to make it to move forward again, we remove the negative sign and make it positive. But in Scratch, the positive side is invisible while the negative side is visible. So that is why we don't do plus 10. It's just normal 10 without any plus or negative sign. So now that we have done the left and right arrow key, like I said, the X axis is for left and right or horizontal, whatever language you want to use, left and right or horizontal. Now let's try and code the up and down, which is Y, or vertical for short. So we'll scroll to where we find change Y by 10, and like I said, it moves up. But as you see, the code doesn't even work because of there's no green flag click. So the only way to make it work is tap on the code and it moves up. So now, like I said, if you want to make it move the opposite, which is down, you do change X by minus 10, and now it moves down, which is the opposite of up. That is why we add the negative sign, and whenever we add the negative sign, it goes to the opposite hand side. Like the positive is change X by 10, which makes it move right hand side to the right hand side, while the negative is change X by minus 10, which makes it move to the left hand side. So that's just like the opposite of the main code for where it's supposed to go. So now we have made the up and the down arrow key. Now let's try and use a ball to demonstrate all these codes we just made. So let me delete all this and delete the sprite one. I'll come here to choose a sprite and let's search for the ball. But most people will be wondering, there are so many other codes in this motion that say change X by 10. But before we get into that, let's first explain all these other codes before that. The first code you see in your motion is move 10 steps. This is literally self-explained. It is just to move 10 steps in the direction you are on. So that is how the move 10 steps work, just to move 10 steps in the direction you are on. Then this one is turn 15 degrees to right and turn 15 degrees to left. As self-explanatory, it just turns the ball to an opposite direction. But as you can see, the ball doesn't show anything because it's completely round and all the sides are equal. But the way to know your direction of your sprite, like for example, if I pick a different sprite, let's pick something that can turn, like this one. If I now pick that same code, turn 15 degrees and this other turn 15 degrees, if you click on it, it changes. But a sprite like the ball, which doesn't show when it moves, the only way to know it is to look at this direction tab here. You can see it says 75. If you make it 90, for example, now if I turn 15 degrees this way, you see it decreases by 50, while if I turn 15 degrees this way, it adds by 50. And the highest direction it can go to is 180, minus 180 and plus 180, or positive 180. There's no other dimension than just the 180. So now let me delete all these codes for now, and let's move to the next code in motion, which is go to random position. This one, it will make your sprite to go to a random position. So now let me give an instance. Now if I put this simple code right here, what I could use to make the clicker game, put it, you can see it goes to a random position without any stop. So the only way to stop it is to do that. And let's go back to motion. So now we have figured out, now there's a code called go to X and Y this. So this code is very like simple. On a normal basis, you can just use the change X by 10 or change Y by 10 to add it to it. But if you want to set it to a specific direction, use this one. But how do you know where exactly your sprite X and Y axis are? This is where you see it here. This one is S because it shows X, while this one is Y because it shows Y and the up arrow, and this one shows left and right arrows. So now that is how you can do it. If you now click on the code, like now the code is -6 minus 66 for the two of them. So this one is at minus 14 and 34. So if we play this code, it changes it to these exact numbers like you can see here. So that is very helpful in case you just want to move it to a specific position without adding. So that's very useful in most cases. Then we have glide 1 seconds to random position. Now the difference between these two is that this one glides, like moves it slowly like this, while the other one just moves it to a random position. So that is the difference. And just in case this goes to random position, if you don't want it to be random position, like let's say I drop this bat here and I want this ball to just go to the bat immediately. So the best way to do that is to come to the ball, this go to random position, click the drop down menu and select the bat. If I'm here and I click on go to random position, he selects the ball. It can never select the same character because then the code wouldn't work and make any sense. So that is why we can select it to go to ball and go to this and that. So now if we click on it, it instantly goes where the bat is staying, like behind it. Like look, let me click on it again. It goes exactly where the bat is. So just for the codes to run smoother, let me put the where green flag click so it can work. And also the glide 1 second works like that. The random position, click the drop down menu and you can set it to glide 1 second to bat. Then it glides from this position, it glides to the bat. It doesn't just teleport there. Then this one is glide 1 second to X and glide 1 second to Y. This is a very simple code. Just like we have this go to X and go to Y, this one is the exact same thing. It works the exact same concept. You can put the exact Y and the exact X, and if you move your ball out of that, then you put on the green flag, it glides to that specific position. Very simple. And let me change the code to a different way so we can see that it truly works. So then if we play it, look at it, just moves exactly to that X. And just to make sure it's correct, you can check out the X and also check out the Y, and it is exactly the same numbers that are inputted here. So now let's delete that and delete this one. Now what's the next code? Point in direction 90. This is very simple. Like I showed you before, this is the direction place here. It's to tell you what direction your sprite is facing. So if we put this point in direction 90, it puts it on a very specific direction. Let me give you an instance with the bats. So now you can see the direction here is 15. So if you click on point in direction 90, and it must only be 90, you can change the number if you like. Immediately it changes it back to 90, the original position. 90 is like the original position for all sprites. Then you can now change it to your own specific direction if you like. Like I can do minus 90, and then it changes it to minus 90 or 90, whatever you want to do with it. So now that we have finished the point in direction 90, the next code you see is the point towards mouse pointer. This one is very simple. Like if I put the green flag, I make sure the other code works with the green flag so you can understand. So if I now put it, whatever sprite, this is the ball, so you don't notice it. So let's use the bat so you can notice the change it makes. So that was point towards mouse pointer. As you can see, it has a drop down menu, so it mustn't only be the mouse pointer, it can be any other sprite that is on your scratch list of sprite that you put. Now it points towards my mouse pointer wherever I put it, which is the bats. It points towards the mouse pointer, but then why doesn't it work? Like, well, maybe something is playing in the background. Yes, now it should work. Oh, it's because of the direction. So what this code initially does is to change the sprite to point where your mouse pointer is pointing. That is very helpful for this stuff. Now you see it's pointing towards the direction where the mouse pointer is pointing. So now let's try other things, not just the mouse pointer. There's ball, because that's your next sprite. If you play it, it points towards where the ball is standing. That is what this one works to do. So now the next one is change X by 10 and set X to minus 91. So now this codes now to most people, they can look very confusing, like they don't understand what the difference is for both of them. So change x by 10, it will just add, like I said, where is the x-axis here? It will just add to the x-axis. Like you can see, the x-axis is minus 71. It adds to it, making it bigger. Now let's make it a positive number. Now you can see it adds 10 to the x-axis. Now is at 59. If I add it again, it goes up to 69, like that. While set x to minus 91, this code, it just sets the x to a specific number. It doesn't like make it just add to it. It sets it to the specific x you want to do it. Like if I make it change x to 90, for example, see that the x shows 90. But if I put the change x by 10, it adds to the x, not that it just moved it to a specific number. It adds the 10 to the x, the correct x-axis, to add 10 to it. That is the difference between set x and change x by the number you put there. So now that we have used those two, there's change y by 10 and set y by 30. This is also the same concept with the change x and set x. This one, it just adds to your y-axis. Like you can see, the y-axis is 30. So if we add to it, it makes it 40. And add again, it makes it 50. While set y to 30, it just adds 30. Just sets the y to 30. It doesn't add anything, just sets it to the number that it puts there. If I put it set y to 50, it just sets your y exactly to 50. It doesn't make it move and add to the specific number. So now we have two more codes inside, the main two more codes. If on edge bounce, this one is very self-explanatory. If the character is on the edge, it will bounce, but this is not for forever. That's why it doesn't like move like that. So we'll change it to forever. Then let me put it on the edge, so it now bounces out. It doesn't want it to stay there, it wants to bounce out. It doesn't want it to stay there, it wants it to bounce out. Then the final code is set rotation style left right. This one, if you get to a specific character that can rotate, it will rotate all round. It rotates the full degrees. But if you put it just left and right, it changes it instantly just to left and right, so it can be up straight. Then we can put don't rotate. It doesn't rotate at all. That's just the beginning. Then we have x position, y position, and direction. This one is just to show where the code is. As you can see, the numbers look very large. This is exactly what they are showing you. This and direction. This is exactly what they are showing you on the screen. But this one is this is the shorter version. This is the long full version, the scientific version. But this is just very short numerical numbers. This one is very long. So this is essentially what they are showing you on the screen. In case it's a game whereby you have to see which x, y, and position and direction you're looking for. If you like this video, don't forget to leave a like, subscribe, and I'll see you guys in the next video. Peace.